Hi there, and thank you for clicking on this video. In this video, I made the decision to cover two different topics. They are related to each other and fall under the umbrella of special cases of factoring, but they are two distinct topics. So if you clicked on this video looking specifically for the sum and difference of cubes, I'm going to cover that first. If you clicked on this video looking specifically for factoring by grouping, go ahead and fast forward to the point in the video. You should see a heading up there when I switch over the topics. I did that because both of these topics are fairly quick to cover, and in terms of making the best use of time, seemed like a reasonable decision to make. So hopefully it will work out for you. Please like this video if you find it helpful, subscribe for more math help, and check out the practice set for this lesson. Now, getting into the sum and difference of cubes, we want to establish what perfect cubes are. And they can be defined as an expression that results from cubing a variable, an integer, or some combination thereof. So some combination of variables and integers, and you raise them to the third power, and the result is something that we call a perfect cube. So I'll go ahead and give you several examples of this. If you just had a variable, okay, then the perfect cube would be something like x cubed. And of course, it does not have to be x. It could be y cubed. You could take an x and a y and multiply them together to get like xy cubed, or you could have that same expression written as x cubed, y cubed. Now with the numbers come from taking our integers and cubing them. So 1 to the third power is, of course, 1 times 1 times 1, or just 1. 2 times 2 times 2 would give us 8 is a perfect cube. Now, a common mistake that I see students make here is just misinterpreting the exponent there. And so I will see a lot of students tell me that 2 cubed is 6, which is just doing 2 times 3 instead of 2 as a factor 3 times. So just be mindful of that. Now, as we look at the cubes, you might notice that they tend to get very big very fast. Oh, that one I wrote out of order, but there you go. So by the time we get to 5 cubed, we're already up into the triple digits. And for that reason, we don't typically have lots of perfect cubes memorized. Once you get past like 5 or 6, typically you might have to go grab a calculator, because we just don't handle those numbers a whole lot. Unlike the perfect squares, which we tend to handle a lot more of before we lose track of whether what we're looking at is a perfect square. Now, the sum and difference of cubes are expressions that add or subtract perfect cubes. So in essence, you could take anything in this group here, including all the many things that I did not write down, and just put a plus sign or a minus sign between them, and you would have the sum or difference of cubes. So for example, you could have something like x to the third minus 125. That would be the difference of cubes. We could have 27x to the third, y to the third plus 1. All right, that would be the sum of cubes, and you got like everything in there being a perfect cube. So how do we go about factoring these? Now there is a formula, and I am not one for just handing students formulas. And if you've followed this channel through a lot of my Algebra 1 videos, you know that I don't really go for shortcuts and tricks. It's all about ground level stuff. Now, coming up with the formula, I have seen students dig up stuff online, like the depths of the internet, where they have factored the sum and difference of cubes using strategies that I had never seen before, and I'm like, where did you get this? But it comes from like a proof of the formula. It's one of those topics that I think we could go through, like a derivation of the quadratic formula, which I do have a video on, but it's not worth it in terms of like efficiency. Because at the end of the day, we just kind of need to remember how to do this. It does not feed into future skills, which is kind of a deciding factor for me. Like, is this piece of knowledge going to feed into a future skill? If it is, we need to lay that groundwork really well. If it's not, if it's kind of a standalone topic like this, then it's not as important. Now, I tend to, when I write the formula, write it as a single formula. And so I would have x, or not x, but a there, a cubed plus or minus b cubed. And so we have the sum of two cubes would be represented by the plus sign, and the difference of two cubes were represented by the minus sign. And then when you factor that, it will always factor into a smaller parenthesis and a bigger parenthesis, and we end up with a plus or minus b times a squared, and then minus plus, so you might want to note that, a times b plus b squared. Okay, and I tend to write it that way because it just saves space. It is often given as two formulas, and so you might encounter in a class, you have the sum of cubes, and that factors into this. And then you'd have a different formula for the difference of cubes, which would be this. And when I have showed that to my classes, I'll ask them to look for patterns in these formulas, like, because if we can see some patterns, we can maybe exploit them. Now, if you're wondering, there is no great reason I put parentheses around that up there. I think that was just habit. I just opened up parentheses. But as you look at it, you can see that there are some patterns. So I'll have students point out like, oh, the plus sign is, the same in both, or these signs here always flip. And that can lead us into what, I don't know if it's a shortcut, but it's a way of memorizing it. Now, I do tend to write it as one. So what you would do if you were reading the one formula is you would just kind of commit to reading the symbol at the top or the symbol at the bottom, but don't like switch halfway through. Now, is there an easy way to remember this? Well, I have got some great news for you. Why? Yes, it's called the SOAP sandwich, all right? And this is a mnemonic device that I picked up from one of my colleagues. It's not original with me, but it is a great way to just remember this, because if I remember when I was in Algebra 2, these formulas completely drained out of my brain in every way. They were inherently unrememberable, at least over the long term. So you can cram them into your brain, pass a test on it, and you don't see sum of difference of cubes a whole lot like in your future math. And so when you needed to dig it up because it just turned up somewhere, like there's not a chance you're going to remember it. But you might remember the SOAP sandwich because it just is more memorable. So the acronym SOAP stands for same, opposite, always, positive. Okay, that's what that acronym stands for. Same, opposite, always, positive. And this is a rule for the operators. Okay, those are the plus and minus signs. So this acronym can get you with the plus and the minus signs in the right spot. And then the sandwich part is for the second set of parentheses. So we've got like the smaller set and the larger set. This one over here is our sandwich. All right, and in the sandwich, we have a slice of bread, and slices of bread are square-ish typically. And so we might say square it, okay, and then square it. In other words, go pick up your two slices of bread. And then in the middle, we have our PB and P. I can do this. I promise I can. Our PB and J, and notice that I have a time sign there, and that's our filling. And so we might say, all right, once you get your, oops, that is supposed to be the word smush. I can't write it though. Smush it together, okay? And so I know I don't have my camera turned on, but trust me, I'm moving my arms around. So one of my colleagues, when she teaches this, she's like a SOAP sandwich, and then she holds up her hands as though she's got a slice of bread on each hand, and she's got the PB on one and the J on the other, and she goes square it, and then claps her hands, smush it together. Square it, smush it together. So the filling in the sandwich is like a product. We're going to multiply stuff together. Okay. Now I'm going to show you how this works. Okay. So we're going to work through how does this little acronym mnemonic device, little rhymey thing, square it. smush it together. How is this going to work to help you remember what this is? So here we go. We have some examples here. So I'm going to start by setting up the parentheses. And the SOAP acronym is same, opposite, always, positive. And this tells me what my operators are going to be. Same means it's going to match the same as what the original problem was. So if the original problem was a minus, you're going to use the same sign right there in your factor. And then O is for opposite. So the next operator is the opposite. So same, opposite, which means this will be a plus sign. And then the last operator is always positive. Now, what I tell my students is in a multiple choice question, go find the operators and now go through your answer choices and eliminate anything that does not have the correct operators. So even if you do not remember the whole rest of this, if you can remember the SOAP part of it, you can maybe double your chances of getting a multiple choice question right, which is really helpful. Now, to get the first set of parentheses, we are going to just exploit what we know about it being perfect cubes. And we're going to ask ourselves, what to the third power gives me x cubed? Well, that is x. And then what to the third power gives me 8? And that is 2. And now we get the sandwich. So we're going to square it, smush it together. What are we going to square? Well, this x right there, we're going to square that and get 1 slice of bread. Then we're going to take the 2 and we're going to square that to get the other slice of bread. And then the PBJ, smushing it together, we're literally going to take the x and the y there, or x and the y, x and the 2, and multiply those together. And that is our filling. Ta-da! There we go. Okay, next example, because we'll do a couple of these for you. So we have the small parenthesis and the big parenthesis, and our operators are the same. So this is a plus sign, so we start with a plus sign. Next operator is the opposite of whatever we started with, and then the third one is always positive. If it's multiple choice, go ahead and eliminate any answer choices that are not plus, minus, plus in terms of the operators. Now, to get that first parenthesis, we need to ask ourselves, what to the third power gives me? And then in this case, it's 64. Well, that would be 4 to the third power. And what to the third power gives me x cubed? Well, that would be x. And you're going to keep those on the left side of the plus sign, just like the 64 and the x cubed were on the left side of the plus sign. And then we say, what to the third power gives me 1? Well, that is 1. Now, when you go to do your sandwich here, okay, we're going to square it. Now, remember, that's going to be 4x times 4x, or 16x squared for 1 slice of bread. Then we have 1 by 1, which is 1 squared, or 1. And then we're going to smush it together. So this is like our PBJ here. 4x times 1 is 4x. Square it, smush it together. Last one. All right, you would be kind of hard pressed to find a sum or difference of cubes that's yuckier than this one. Here we go. So we're going to do same, opposite, always, positive. So this is the sum of cubes. And now we need to just ask ourselves, what to the third power gives me, or what cubed gives me 27? Well, that is 3. What cubed gives me x to the third? That's x. What cubed gives me y to the third? That's y. So our first term there is 3xy. On the next one, what to the third power gives me 8? Well, that is 2. And what to the third power gives me z cubed? Well, that is z. And there's that first one. And that takes maybe a little bit of practice. Again, I mentioned earlier that your perfect cubes get big, like really, really, really fast. So you don't really see much beyond like the first 5 cubes. All right, so now we need to square it. All right, so we've got 3xy times 3xy. That's going to be 9x squared y squared for 1 slice of bread. The other one is 2z times 2z, which is 4z squared. And then we're going to take those two things, 3xy times 2z and smush them together, and I get 6xyz as my sandwich filling. Square it, square it, smush it together. So there you go. Sum and difference of cubes with a little bit of background. About 15 minutes to go through the entire lesson. So a very, very short lesson if you're just doing it by itself. So factoring by grouping. Now, if you have fast forwarded your video, you hopefully have found us here. So factoring by grouping is sometimes used as a primary strategy for factoring trinomials. I do have a comparison contrast video, which I will link up here for you if you'd like to see how that strategy compares to others. Compares to others, and you can check that out. But I tend to use it when I am dealing with expressions that have 4 terms. Now, it doesn't always work, but it is worth trying. If you've got higher, like messier polynomials, is to try a grouping strategy and see what happens. And it can be extended and applied to other polynomials. I'll stretch the boundaries of that a little bit in the practice set so that you can see how it would look, maybe like stretching it a little bit. All right, so with factoring by grouping, again, I tend to use it with expressions that have 4 terms, and I use the area model. If you've followed this channel through all of the Algebra 1 factoring, you know that I subscribe to something called the area model for factoring. And this model is particularly awesome for factoring by grouping because all you do is put each factor into its own, or each term, sorry, into its own box. And now I'm going to do GCF factoring, and I really only need to do it one way. So you can do the greatest common factor between x to the third and 3x, or the greatest common factor between x to the third and negative 4x squared, whatever you like better. I'm going to go ahead and factor out the x squared. And now you can use multiplication for the rest. So x squared times x gives you x to the third, x squared times negative 4 will give you negative 4x squared, and 3 times x gives you 3x, and 3 times negative 4 is negative 12. And so our factors are written on the side. So we have the base and we have the height, and we're literally done factoring. It is that simple and that easy to look at, like visually. Now, you want to be mindful of the fact that you might not be done. So once you do the factoring by grouping, you might have another step to take. So let's take a look at what that might look like. So I'm going to do GCF factoring. We'll go this way this time. So the greatest common factor between x to the third and negative 4x is x. And therefore, that would have to be negative 4. Since negative 4 times x would give you negative 4x. This would have to be x squared, which means this has to be 5, and then you can check negative 4 times 5 is negative 20. And so my factors are x squared minus 4 and x plus 5. But notice that this factor right here is a difference of squares, not to be confused with the sum and difference of cubes. This is a difference of squares, and this will factor into my conjugates, x plus 2, x minus 2. And so if you want to get it completely factored, there is an additional step to take there. And that's pretty much it for factoring by grouping. It's kind of a non-event. Now, just for the experience of seeing an alternative layout to this, because most people will do this in a more horizontal layout, what they'll do is they'll factor it horizontally. And when I show this to my students, what I do is kind of what I'm doing right here is I split it up by color, okay? And I say, okay, now we're going to factor the red part and we're going to factor the green part separately. I haven't done any algebra here, okay? I just changed the color. And so I look at the red part only, and I say, what's the greatest common factor in the red part only between x to the third and negative 4x squared? Well, that would be x squared. And so I factor that out, and I'm left with x minus 4. And then I repeat the process with this. I say, what is the GCF between 3x and negative 12? Well, that would be 3. And that leaves me with x minus 4. And you could check each of those. X squared times x is x to the third, negative 4x squared, 3x, negative 12. Now I'm going to do another little rewrite on this. What we have now is a common factor of x minus 4. And what I'm doing is another like just colored step so you can see it. You can see that we have a common factor. Now, if you were to have, say, 4x squared or x squared plus 3x squared, and you were to take out the x squared, it would leave you with like 4 plus 3, like basically whatever was left. We're going to do the same thing right here. We're going to factor out the x minus 4. Okay, that's like taking out the x squared. And then what we're left with is the x squared plus 3. And essentially what you're doing. And then just for our final step, I'll just like put it all in the same color. All right, and that's the alternative layout. It is exactly the same thing that we did on the previous page, except that it's laid out on the page horizontally. It also doesn't make some of your alternatives with the area model. You have different places where you can start with this. This you would probably be locked into starting with the first 2 terms, whatever those happen to be. But my experience with students doing it this way is they can generate the right answer, but they're really not seeing the common factors, especially the common factor of x minus 4. Like they just don't see it as a common factor. Some students do, but it is a lot more challenging. And so I am a big advocate of laying it out like the area model. Okay, that was the whole lesson. So less than 22 minutes. Now you know why I thought, yeah, we can totally do this in one lesson. Please don't forget to like and subscribe if you found this lesson helpful, either part of it. Drop a comment or question to engage. If you really think this should be 2 separate lessons, like let me know. That's obviously something I can do. And check out the practice set for this lesson. Oh, look at that. But also I'm not re-recording a video after 22 minutes. So this lesson and some of the other lessons that we have on the channel. So that should be linked below. Thank you so much for being with me on this lesson, and I hope to see you in the next one.